Hello friends, so let's continue doing question number 86. A load consisting of three equal resistances of 40 ohms connected in delta is put across a 400 volt three phase AC supply. The line current taken by the load. So whatever value is given in the question, it's the line value, that is 400 volt is VL. VL is equal to 400 volt and it is a delta connected system. We have to get the line current taken by the load. We have to get IL, and the load has only resistances in it and it is 40 ohms, isn't it? Okay, so IL is equal to VL by I phase is equal to V phase by R. So it is 400 divided by R is 40. So it is 10 ohms. So I phase is 10 ohm. We have to get IL. Since it is a delta connected, IL is equal to root 3 I phase. So it is 1.73 into I phase is 10. So 17.3 ampere is the right answer. Option B is the right answer. Moving on to next question. Question number 87. Load in each branch of a delta connected balanced 3 phase 400 volt 50 hertz circuit consists of an inductance and series inductance of this much value series with the resistance. Calculate the total power consumed by the circuit. It's also a delta connected system, and in that you have an inductance and a resistance in series. Inductance and the resistance. And we have to get the total power in the circuit. You know that there is power consumption only in resistors, not in inductors. So we have to get the power of individual resistors, and or let's find out the power consumption in one of the resistors and multiply by 3. Okay, so 3 I phase square. So the current passing through each arm is phase current, isn't it? So I phase is the current passing through the resistor. So I phase square R. This is the power consumption in one resistor multiplied by 3 will give the power consumption in whole load. Okay. So 3 I phase square R is the equation. We have studied another formula like 3 V phase square by R. But this cannot be applied over here because we have to get the voltage. See, the voltage which is written here should be the voltage across the resistor. Then only the power consumption will be got, because power consumption takes place only in resistor, not in inductance. So when I apply this formula 3V square by R, I have to get the voltage value which is appeared across the resistor, and that is something lengthier to do with. So instead of this 3V square by R, let's move with this equation, that is I square R multiplied with 3. I square R and V square by R both are power equations, but since it is easier to get the I phase value or the current value through the resistor than the voltage value across resistor, we will go with this one, I phase square R multiplied by 3. 3 is multiplied because it is a 3 phase system, have 3 resistors in this load. Okay, so the details given in the question, it is a delta connected system, it's already noted. 400 volt is the line voltage, VL is equal to 400 volt, 50 hertz is the frequency, and L value is 31.8 millihenry, and R is 10 ohm. Okay, so R is 10. Have to get this I phase. So it is 3 into I phase is V phase by Z phase whole square into R is 10. Now V phase value, V phase is equal to VL for a delta connected system. So it is 3 into V phase is 400 divided by Z phase into 10. Now it's time to derive Z phase value. Actually it is Z phase, if I split the numerator and denominator, like if I split this bracket, it is 400 square divided by Z phase square. Why I write it as Z phase square means Z phase square is equal to XL square plus R square. What is XL? XL is the inductive reactance. XL is 2 pi FL. Okay, whole square plus R square. Now 2 into 3.14 into F value is the 50 Hertz into L value is 31.8 millihenry. Whole square plus R square. What is R? Resistance is 10. Okay, 10 square. So let's do this lengthy numerical. 2 into 50 is 100. 100 into 3.14 is 314 into 31.8 into 10 raised to minus 3 whole square plus 10 square is 100. Now there is a 10 raised to negative 3 over here. So I have to shift 3 places, isn't it? This point should be, the decimal point should be shifted to left, towards left side 3 times. So I will shift this point once in this numerical, that is 31.8. It becomes 3.18. And the rest 2 shifting is done in this number. So it is 3.14 whole square plus 100. So it is around 3. It is just like 3.1 into 3.1. It is around 9. Okay. So it is coming about 9 point something. So 9 point something whole square plus 10 square, which is 100. So 9 point something, I round it to 10 itself. So 10 square it is 100. 100 plus 100 it is 200. Okay, substituting this set phase square value over here. 3 into 400 square is 16,000,000 divided by set phase square is 200 into 10. So it comes about 16 by 2, 8. 8 into 3, 24. 24,000. 24,000 is the power consumption. Option C. Option C is the right answer. 87C. Okay. Moving to the question number 88. 300 ohm resistances are connected in delta and are connected to a 400 volt 3-phase 50 hertz AC supply. If one of the resistance is burned out, what will be the reduction in power? It is a delta connected load first, isn't it? It is a delta connected resistance combination, and it is said that one of the one of the resistance is burnt out. So actually the supply is given to these points, and when one of the resistors burn out, you will be left with the other two, and the power consumption will be never affected for these two resistors. There will be reduction of power for this resistor only. So how much power is in one resistor? It is I phase square R. I phase square R, I phase square R, I phase square R. That is how you get 3 I phase square R power, the total power consumption, the load. But when one of these resistors is burnt out, you will have a reduction of power, which is of value I phase square R. Okay, now let's find the value. What is I phase? I phase is V phase by Z phase. The impedance just have the resistance. So V phase by R whole square into R. V phase is equal to V line because it is a delta connected one. So it is 400 itself. So 400 divided by R is 100. 100 whole square into 100. So it is 4 square 16. 1600. 1600 watts will be reduced. Okay, so option C. 88C. 89. 3 equal resistance of magnitude 5 ohm each are connected in delta. The resistance between any two pair of terminals. In this sentence I am confused with this line, any two pair of terminals. I will get back with the same question in the next video. Let's skip that for now. That is question number 89 will be discussed later. And the last question for this session. So in total there will be only 4 questions discussion done in this video. Anyway, I'll come back with this soon. So last question 90, question number 90. What is that? A 400 volt 50 hertz ABC system of voltage is applied across three delta connected identical inductors of reactance 4 ohm. So this is the XL value, reactance value, the line and phase current. You have to get IL value and I phase value. This is a delta connected system. So for delta connected system, IL is equal to root 3 I phase. Okay, now IL, yes, the inductive reactance is given. See, there is only inductors present in the load. So, Z phase is equal to XL. There is no R coming up here and XL value is 4. Okay, so Z phase value is 4 ohms. Now, I phase is equal to V phase by Z phase. What is V phase? Since it is a delta connected system, it is VL by Z phase. So, VL is 400 divided by Z phase is 400 is your I phase. IPH is equal to 100 ampere. Now what is IL? IL is equal to root 3 times I phase, that is 1.732 into 100. So 173.2 ampere. Check the order, line and phase. So line is 173.2, phase is 100. 173.2, 100. Option A is the right one. We'll get back with the next set of questions. Thank you.